In the previous part of the mesh generation, we produced a mesh within the backward facing flow. So in this part, the third part, we will introduce how to generate the prism layer to resolve the boundary layer. So we know the boundary layer is because of the fluid viscosity. So there is a very thin layer. It's called a boundary layer, and this boundary layer theory was proposed by Pronto at the beginning of 20s. At the beginning of 90s, and so this is very important, and also important to resolve the near wall structure, especially for flow separation, and also when we deal with turbulence. So in STAR CCM, we have this capability to generate the prism layer. So now we need to go back to continuum and a mesh. So we need to update the mesh models. So we right click and then select meshing models, and you can see we have the prism layer measure. So in the STAR CCM, it's called prism layer. In the other software, it's called boundary layer mesh. Okay, so once we enable this prism layer mesh, it's included in the enabled models, so we can close it. So in the prism layer, and it will be showing in here, and the values will be in this part, reference values, and we can see there are some parameters that need to be determined. For example, the number of prism layer stretching, and the prism layer thickness. Okay, so let's go to the thickness first of all. And so there's relative value and absolute value. So let's see, we can do some estimation. And so the thickness of the prism layer, as the layer is intended to resolve the boundary layer. So let's, for this type of flow, we can say the boundary layer be 2, like 5 centimeters maybe, and so 0.5. So that's absolute size. We enter it to update. And the number of prism layers. The number of prism layers, we can say how many, that many means how many grades we have to resolve the boundary layer. Let's say 21. Apparently 2 is not enough. And also we can see prism layer stretching. So that means how the ratio from one layer to the other. Maybe 1.5 is too large. Let's say 1.3. And all these parameters are not definite. So we can either do it based on the experience or by try and error. Okay, because I don't know what's the boundary thickness so far, but later on, once the calculation is done, we can have a look and then update the prism layer size. Okay, then it's done. We can update the mesh. So by clicking this button, so you can see the mesh is being generated. Now you can see there is a mesh in here. Okay, so that's a prism layer, and you can see it's very thin when it's very close to the wall. Okay, so this is about how to generate a prism layer mesh to resolve the boundary layer. Now you can see there are 2 lines at the inlet and the outlet, and there are also prism layer which are actually not needed, because we will have flow into it and flow out of it. You know why? Because so far the type of the boundary is still wall, so only wall need to be resolved, right? Near wall region. So this part is still the wall. Now if we go to regions and boundaries, so if we change the type of the inlet and outlet, so it's wall. So it's not supposed to be in this part to change it, but we can change it now and to see. Okay, and we will redo the explain the boundary layers, boundary conditions later in detail. But now for the purpose of making the mesh correct, so we just set the inlet at velocity inlet, although it's mission later. Outlet is the let's say pressure outlet. Okay, and then we can update. So I believe there won't be prism layer at the inlet and outlet. Okay, so you can see it doesn't exist because originally it was by default the inlet and outlet was a wall type boundary condition. Okay, so this is what we have and how to generate a prism layer. So in the next part, we'll set up the simulation models and the boundary conditions. Okay.